Okay. Okay. So we are done up to this part.
Yes, sir.
Next thing is how to calculate surface tension numerically. The next is calculation of surface tension. Suppose you have any rod placed over any liquid, and just considering this rod is massless, so it will experience a force only due to its surface tension. So if you try to calculate the interacting surface of this particular rod over this liquid, so on viewing this from front side, suppose this is your rod, and if you are seeing this particular term from this side, so it will behave like this, any circular object. So liquid will be all around. Like this. So there will be force of attraction between liquid molecule and solid molecule at this interface. So there will be surface tension at the interface of separating medium. So one will be along this direction and the other will be along this direction. Is it clear?
Yes, sir.
So how many interaction do we have in case of this rod? So you will say 2 different interaction. And for each cross-section area, this cross-sectional area, this cross-sectional area, for each cross-sectional area, it will have some interaction. So if you have to calculate the total force exerted due to the surface tension from this end to this end will be the total length of its interaction, we can say.
Yes.
So experimentally, it was calculated using this concept. So surface tension equals to force required to uplift this particular object divided by length of interacting boundary. So it is nothing but force per unit length.
Yes.
So if you define unit of this particular surface tension according to this formula, you will get force to be Newton, and for length it will be meter.
Meter.
So its SI unit will be Newton per
Newton
meter.
per meter.
So SI unit Newton per meter. Do you know any one more quantity which having same unit as Newton per meter? Spring constant.
Yes, sir.
Or force constant. K, which is also equals to force by length. So it will have same unit as that of surface tension. So you will be asked which physical quantity will have same unit as that of surface tension. So you will say spring constant or simply force constant. Now, related to this formula, let me define. First, if you have any hollow disk, this is any hollow disk. So in this part, we have one length of interacting boundary from inside and one length of its interacting boundary from outside. So surface tension related to this part will be force divided by length of its interacting boundary. That will be 2 pi r from inside, and length of its interacting boundary from outside, 2 pi capital
2
R.
pi r.
So 2 pi to be common, so it will be just r plus r. Is it clear?
Yes, sir.
Similarly, you may define in case of ring, in case of ring, small r becomes equals to capital R, or you'll say thickness becomes 0. So small r becomes equals to capital R. So if you put this value in this expression, you'll get T equals to F by 2 pi R plus 2 pi R.
2 pi r.
So it will be F by 4 pi R. Okay.
Yes, sir.
Now in case of rod, it will become straight line. So 2 pi R, 2 pi R becomes L. So surface tension will be F by L plus L. That will be F by
12.
12. And so on. We can define formula for any different objects related to this concept. Just write it down.
Answer.
Now let me define you a question related to this part. A square ring having side 2 centimeter, massless, is on the surface of liquid having surface tension 0.005 Newton per meter. Find force required to uplift it. Just tell me how you will solve.
So we'll apply the formula here. Like we have given the surface tension. So put the values.
Okay.
And
so what would be
it's a
formula
ring.
related to this?
It's a,
We have a square ring.
according to ring, it is F by 4 pi r.
But we have square ring and having side
Yeah,
2
we have a
centimeter.
square ring.
So for
Side
square,
tension.
the length of its perimeter will be nothing but 4 times of its side.
Yeah.
Okay. So in this case, we can transform 2 pi r or 2 pi r equals to 4 times of its side. Okay.
Yes.
So
Okay.
surface tension will be equals to force divided by 2 pi r, that is 4a, plus 2
4a.
pi r, that is 4a. So in total, it will be F by 8 times
8a. Yeah.
So just put the value of all related term in their SI unit and simplify it for force. Try to solve.
Sir,
Yes.
0.008.
If you transform this part, it will be 8 times A into T. So 8 multiplied by A is 2 centimeters. So it will be
16.
2 divided by 100.
Yeah.
Into surface tension, that is
0.005.
So remove this decimal, so you'll get 10 to the power 3.
Yeah.
2 into 5 will be 10.
10.
So 8 into 10 divide by 10 to the power 50. So
5
1 0
zeros.
1 0 cancel out. So you'll have with 10 to the power 40. Or you may write 8 into 10 to the power minus 4 Newton.
Yes, sir. So I got the correct answer, right?
Good.
Yeah, correct answer.
Any doubt related to this part?
No, sir.
Now there will be some application of this particular term. Let me define you. Work done to form bubble or drop, or that will be also called surface energy. Work done to form drop. Suppose you have initially a drop of this much radius. So if you want to expand this particular radius, so you must have to apply some work against its surface tension to increase its surface area or to increase its radius from this initial part to this final part. Let's say the radius of this drop initially is r and is being changed to delta r by applying some work to this particular drop. So let work is done against its surface tension to increase its radius. So work done equals to simply force times displacement. Force in terms of surface tension, it will be surface tension multiplied by length of its interacting boundary times delta r, we can say.
Yes.
This length into delta r, that is breadth. So length and breadth will combinedly define you change in area. So we can write T times delta A equals to net work done. Is it clear?
Yes, sir.
But this is only for drop. Let me define you how to calculate or how to use this formula in case of bubble, or what would be the main difference between those two different objects. So there will be concept of interacting surface for three-dimensional object. Suppose you have bubble and drop. What would be the main difference between these two?
Bubble and drop.
You'll say air. For drop, air will be outside of it, but for
Yeah.
bubble, it will be
It
both
will be inside.
inside as well as outside.
Yeah, inside and outside.
So if I ask you how many surface is being directly exposed to air for case of bubble,
All of those. Inside.
I'm just considering inside to be one surface and outside to be one surface.
Okay.
So how many surfaces in case of bubble do you have directly interacted with air?
2.
Good. So number of interacting surfaces for bubble, it will be 2. And in case of drop, it is
1.
good. Depending upon number of interacting surface, we may transform the above formula as work done equals to 2 times of T delta A. And similarly, in the case of drop, it will be just 1 times T delta A.
T delta A.
Any doubt?
No.
Okay, just write it down.
Second, scroll down. Thank you. Done, sir.
A source solution having surface tension 0.006 Newton per meter. Find work done to increase a radius of bubble formed using it from 2 mm to 5 mm. Just use the above formula and try to find. We have surface tension, this.
Yes.
Calculate your values in terms of pi.
So
Yes.
I'm getting 0.036.
Since we have to calculate for bubble, so we use this first formula. So work done
Yes.
equals to 2
2.
times T delta A.
Yes.
So 2 T is surface tension, that is 0.006.
Yes, sir.
Change in area, it will be 4 pi final radius square minus initial radius square. Why it is 4 pi? Since it is sphere. Okay.
Yeah.
So just multiply it. So 2 into 6, or just take decimal. So 2 into 6, 12 into 4, 48.
48.
Pi divided by 1000. Final radius is 5 mm.
5.
So on squaring, 10 to 25.
25.
Initial radius 2. On
2.
squaring, it will be 4.
4.
And 1 mm equals 10 to the power minus 3 meter. And on squaring, it will be 10 to the power minus 6. So 25 minus 20 minus 4, it will be 21 into 48. So it will be 48 into 21 pi into 10 to the power minus 6 divided by 1000.
21 minus 3.
So it will be 48, 96, 8, 12, 9, 110. So it will be 1028 into 10 to the power. If this 1000 will move to numerator, it will become 10 to the power minus 3. Or if you move decimal, you may write it as 1.03 into 10 to the power minus 6 joule.
Okay.
Is
Sir,
it clear?
1 minute. Yeah. 1 minute, sir.
Okay.
Done, sir.
Now there will be some question. Combination of drop or bubble. Suppose we have a number of small drop. Which tend to combine to form single large drop. So first, can you tell towards which side do you have more surface area exposed to air?
More surface right side, sir.
The right side, that was for single particle. Okay, let me give information.
Left side, sir, because yeah, small side.
Suppose this is your finger like this.
Yeah.
So if it is exposed to air, so only this surface and this surface is directly exposed to air.
Only
but
the outer part, yes.
If I spread out like this,
yeah.
So it have more surface area exposed to air in this case.
Yes, sir.
So the smaller the object, it will
More
have
than
more area exposed to air, and larger it gets combined, it will have least surface area exposed. So this will have more surface area and this will have less surface area. By using the above formula, since work done proportional to change in surface area, and for a smaller drop, you will have larger surface area exposed as compared to larger one. So greater the value of area, it will have greater surface energy. Smaller the area exposed, it will have smaller energy. So towards which side we have larger energy and smaller energy?
Greater the area, so right side has more energy.
Which part we have greater surface area exposed?
Single particle.
Good. So single particle will have larger surface area exposed, so it will have more energy, and in right hand side we have less energy. So we can say this particular reaction is going from high energy to some lower energy. So which type of reaction we call it? Endothermic or exothermic?
So can you repeat? I can have some fluctuation.
Which type of reaction will it be? Endothermic or exothermic? Since it's going from high energy to lower energy.
Exo.
Good. So we can say during this process, some amount of energy may get evolved. So you'll be asked how much energy will evolve, and if that energy is being used to change the temperature of that single particle or to change the velocity of that single particle. So try to calculate velocity or change in temperature. So let me define you how to calculate those terms related to this. So first we can say volume of object initial, volume of object final must be equal according to conservation of matter. Initial volume is 4 by 3 pi r cube, and since we have n number of drops, so multiplied by n must equals to 4 by 3 pi r cube. So 4 by 3 pi cancel out. So capital R will be equals to n to the power 1 by 3 times small r. Is it clear?
Yes, sir.
So net change in energy will be equals to surface tension times change in area. Surface tension, change in area is 4 pi r square, and we have a number of drops, minus 4 pi capital R square. So T n times 4 pi small r square minus 4 pi. Just convert capital R in terms of small r. So you'll get n to the power 2 by 3 times r square. Now take out 4 pi r square as common, multiplied by t, n minus n to the power 2 by 3 equals to change in energy during this process. Is it clear?
Yes, sir.
Now, if this energy during this process provides a single particle some velocity, so convert this energy in terms of kinetic energy. If this evolved energy provides velocity, so you may convert this energy equals to half mv square, and on equating them, you'll get velocity of that single drop. Similarly, if this evolved energy provides temperature, so just use delta E equals to ms delta theta, that is a specific heat, which we'll describe in next chapter. Okay. So depending upon depending upon situation, we may use delta E equals to half mv square if this energy provides it velocity, or in terms of ms delta t or delta theta if it is providing that particular single particle as temperature change. Is it clear?
Yes, sir.
Okay, just write it down.
Done, sir.
Okay, so this is all about the surface energy and work done to increase or decrease surface and so on. The next concept is pressure difference due to shape of meniscus, which is also called excess pressure. So let me define you. Suppose you have any curve meniscus of a particular liquid, which may separate two different medium. There will be liquid towards this side. So surface tension may be acting tangentially to this direction, and for this part it may be acting tangentially to this direction. So if you draw a horizontal line and a vertical line, so the surface tension may be inclined at some angle theta. So it will have a component along this way, t cos theta, and this way, t sine theta. Similarly, for this, t cos theta and t sine theta. There will be pressure from outside, P outside, and there will be pressure from inside, P inside. Now let me define you the shape of this meniscus from both sides. Along this side, it will be concave, and from this side, it is convex. Is it clear?
Yes, sir.
Now, at equilibrium, net pressure from outside and net pressure from inside becomes equal. So you can say Pi equals to P naught plus pressure due to 2t sine theta. So if you have to compare Pi and P naught, so which one will be more stronger? Harsh?
Yes.
From this
PI.
expression, if I ask you, which one is more stronger, Pi or P naught? This one or this one?
I guess PI.
Good. And Pi is towards which side? Concave side or convex side?
Towards convex, sir.
Pi is towards downward, that is concave.
It's towards downward. Okay.
Just see, this is concave towards Pi is existing towards upward, and this is convex from outside where we have
Yes.
P naught. Okay. So you
Yes.
can say Pi is greater than P
Yes,
naught.
sir.
So pressure towards concave side is greater than pressure towards convex side. So just remember,
Convex side.
so pressure towards concave side is always greater than concave side, a convex side. Any doubt?
No, sir.
Now, how much would be the difference between these two terms? We have to calculate that part. So, which is also called excess pressure. So first write it down to this.
Done, sir.
Okay. So we have to calculate how much the pressure difference between these two terms. So we have to calculate that part. Before that, let me give you a question related to this concept. You'll be asked, suppose you have any meniscus like this, in which liquid is at this point. One of the meniscus is this, and one of the meniscus is this. So let's say this is 0.1 and this is 0.2. This is 0.1, 0.2, 0.1 and 0.2. So you'll be asked towards which side we have more pressure,
Yes, sir.
1 or 2 in each of the following. In first part, P1 and P2, which is more stronger?
So
In
2.
second, good. In second,
Second, they're equal, sir.
good. Third,
Sir, 1 is greater.
good. So depending upon their curvature, we may define pressure difference. So next we have to calculate how much the pressure difference between these two terms, which is called excess pressure. So next is suppose this is any drop having initial radius r. So it will have some pressure from inside, that is Pi, and outside P naught. It having radius r. So due to this pressure difference, it will tend to expand from some initial radius to r plus delta r. Is it clear?
Yes, sir.
Due to excess pressure, let drop is getting expand from r to r plus delta r. So we have to calculate some relation. First, work done equals to force times displacement. If you put the value of force in terms of surface tension, it will be T L delta A, and length into delta A R will be nothing but change in area. So it will be T times delta A. Is it clear?
Yes, sir.
So if I have to calculate change in area, so it will be 4 pi r square, that is r plus delta r, minus 4 pi r square inner radius. So take out 4 pi as common and just square it. So it will be a square b square plus 2ab
2ab
minus r square. R square cancel out.
Yeah.
Delta r being very small, so on squaring it will become much small, so we can neglect it. So on left with 8 pi r delta r. Is it clear?
Yes, sir.
So if you put this value in this expression, you will get work done equals to 8 pi r t times delta r Let's say this is equation first. Further, we can solve according to pressure this formula. Again, we can write work done equals to force times displacement. Force is equals to net pressure. So we have Pi minus P naught, net pressure into area times delta R. So area of sphere at this condition, initially, it will be 4 pi r square. So Pi minus P naught multiplied by 4 pi r square times delta R. Let's say this is equation 2. Is it clear?
Yes, sir.
Now just compare equation first and second. We have same quantity work done in both equation. Harsh?
Yes, sir.
So we have same quantity work done for both equation first and second.
Yes,
So
sir.
on comparing, we can say Pi minus P naught multiplied by 4 pi r square
Square
times delta R equals to 8 pi r
I
t times delta R.
delta R.
So delta R cancel out.
Yes, sir.
4 pi r and 4 pi r will cancel out in 2 times.
Yeah. A.
So Pi minus P naught will be equals to 2t by r. So this will be our final expression, that how much is the excess pressure do we have towards concave side with respect to convex side. Is it clear?
Yes, sir.
Okay, just write it down. I think you have been told to give your viva today.
Yes, sir.
Okay, have you prepared?
Yes, sir. Mechanical property of fluids. Oh, sorry, like solids.
Okay, just you may take a screenshot.
So I can scroll down. Done, sir.
Okay. So which topic you have prepared?
So like all of
In which,
them.
okay, in which topic you are more confident about? I will just ask you basic question.
So mostly I learned about like definitions of elasticity, plasticity, and
Okay.
stress, strain.
Which stress will define only for solid?
Which stress?
Yeah. We mainly have 3 different stress. That is longitudinal,
Only for normal and
that is normal, shear,
yeah,
and
and
volumetric.
tangent. Yeah,
Shear is
volumetric.
tangential. So we
Okay,
mainly
shear.
have 3 different. So in which case it will define only for solid?
Only for solid stress. So longitudinal.
Okay. And which stress we can define only for fluid?
Shear.
Shear is defined for change its shape. Okay.
Change.
And for
Oh,
fluid,
yeah, it's a change.
we can't define any specific shape to it. Okay.
Yeah.
For solid, you can define longitudinal, shear, as well as
Shear.
volumetric, all of
Yeah,
3. But
all
for
of three.
fluid, we mainly define only bulk
Volumetric.
modulus, volumetric part.
Yeah, volumetric thing. Yes.
Tell me the unit of shear strain.
Unit of shear strain.
Yeah. What is a strain?
So strain is like deformed shape by original shape.
Good. So what would be the unit of deformed shape and original shape?
Theta. Deformed shape by original shape unit.
Let's say deformation is along length. So it will measured in
Yeah.
meter.
Yeah,
And
meter.
its original length will be also length. So it will again have same unit meter.
In meter.
So meter
Yeah.
and meter will cancel out. So you'll get
Nothing. Unitless quantity.
good. So strain will be unitless
Oh,
quantity.
yeah, strain is unitless quantity, sir. I forgot.
Whether it will be longitudinal stress, shear strain, and volumetric strain. Okay.
Yes, sir. Yeah.
Tell me about tensile stress.
Tensile stress.